Hello everyone, welcome to this session on arithmetic progression. So this is the concept series session on arithmetic progression. We typically have three kind of session: the concept series session wherein we build certain concepts, followed by the practice series session where we practice these concepts with certain questions, and then finally we move on to the mastery series session. So this particular session is the concept series session on arithmetic progression, and we will learn various concepts related to arithmetic progression. We'll basically start by understanding that what exactly is an arithmetic progression. We will follow that with the next topic, which is basically how to identify whether a given progression is an arithmetic progression or not. The next topic would be to find the nth term or the general term of an arithmetic progression. So we'll do two variations here. One is if we have to find the nth term or the general term from the starting, and the other variation would be if you want to find the general term or the nth term from the ending of an progression. Finally, we'll move to the last concept, which is basically finding the sum of n terms of an arithmetic progression. So if you are given a progression, if you want to find what is the sum of the first 5 terms, 10 terms, 15 terms, 50 terms, then how exactly we can do that in the form of a formula. So let's get started with these concepts related to arithmetic progression. Okay, so what you see here basically is a series of steps which this monkey is going to jump. So this monkey, let us say at the starting, he is on the first step, which is at a height of 1 feet, and then he'll make a jump and go to the next level, which is at a height of 4 feet, followed by the next step, which is at the height of 7 feet, then 10 feet, 13 feet, and 16 feet. So this monkey keeps jumping from one level to another. Now what we see here, let's try to understand this particular series of numbers. So we are talking about 1, 4, 7, 10, 13, followed by 16. Now if you see, when this monkey jumped from the first level to the second level, it kind of jumped a height of 3 feet. When it did the second jump, again his height increased from 4 feet to 7 feet. So effectively the jump which he's making is for 3 feet. Now we can similarly find that all the jumps he's making are basically increasing his height by 3 feet. So what we can say about this particular series of number? We can say about this series of numbers that this is a series of numbers where, let me call the first term, basically a1, let me call it as the first term, and in this case that term is nothing but having the value as 1. Now there's one number which is constantly being added in this series to obtain every subsequent term, and that number, let me call that as D, or the common difference. So that is the common difference, which is the number which we are adding to every number, every current number, to obtain the subsequent number. Now in this case that number happens to be 3. That number happens to be 3. So what we are seeing is this is a series of numbers where the first term was a, and to obtain the second term, what we did is we added d to the first term and we got the second term, which is a plus d. Now to obtain the third term, we added d 2 times to a, so a plus d plus d. That is how we obtained 1. We added 3 to that, we again added 3 to that, and we got 7. And how did we get the fourth term? For getting the fourth term, we added d 3 times. So that is basically 1 plus 3 plus 3 plus 3, and that is how we got this value as 10. So this is basically the definition of arithmetic progression, where we say that a series of number where every subsequent term can be found by adding a fixed number to the current term. So fixed number is the important part here. Now, one important note I will share here is that in this particular example which we discussed, the value of d, or the common difference, was positive. This was a positive number. So in this particular case, we saw this as positive 3. This could have been a negative number as well. The common difference can be negative as well. So the common difference can be positive, the common difference can be negative, and the common difference can be 0 as well. So if it's positive, it's an increasing progression. If it's negative, it's a decreasing progression. And if you are talking about a common difference of 0, then what are we basically referring to? We are referring to a series in which all the numbers are basically one and the same. So I hope the definition of arithmetic progression is kind of clear with this particular example. Let's move on to a few very simple examples just to give you a visual clue here. So what you see here is you have one truck, you have three trucks, and you have five trucks. Again, these three numbers are in arithmetic progression because every time to get the next term you are adding 2 to it. You have 2 cherries here, you have 4 cherries, you have 6 cherries, and again you are just adding a 2 to obtain the subsequent term. This is another example with trucks, 2 trucks, 5 trucks, 8 trucks. So again, in this case the common difference is 3. So in this case, the first case the D was 2, the second case the D was 2, and in the third case the D is 3. And what happened with the value of A1? A1 was 1 in this case, A1 was equal to 2 in this case, and A1 was equal to 2 in the last case as well. So these are some examples of arithmetic progression, some very simple examples just to get you a visual cue of what we are talking about. Now let's move on to the second concept, which basically says that if you are given a particular series of numbers, how exactly do you find out whether this is an arithmetic progression or whether this is not an arithmetic progression? So let me write down this series 2, 5, 8. We are kind of again having a series here which you see is having the common difference D. So what exactly we do here is we call out these numbers as A1, A2, A3, A4, A5, A6, and A7. So these are series. This is a series with 7 numbers, and what we do is we try to find out what is the number which was added to obtain the second number to the first number. And in this case what we see is that basically 5 minus 2 was 3. Now let's similarly try to find out that what is the difference between the third and the second number, and that comes out to be another 3. Then 4 minus 3, that is 11 minus 8 is equal to 3. Then the fifth term minus the fourth term is 14 minus 11 equal to 3. Sixth term minus the fifth term, 17 minus 14 is again 3. The seventh term minus the sixth term is 20 minus 17, that is again 3. So what you are observing here, what we are observing here is that if you take any term, let's say ak plus 1, and you subtract the previous term from it, which is ak, then what you observe, what is the difference which you get, is always a constant. This number is always D in this case. So if you are having a scenario like this where a series of number is there, and when you find the difference between any two consecutive terms, that is a2 minus a1 or a5 minus a3 or a4 minus a3, or for that matter if you find any ak plus 1 minus ak, and if all of them give you the same value, a constant value, a constant number is being added to get every subsequent term, then basically this is an arithmetic progression. To basically say, I want to take one more example here. I'll probably take it in the same sheet here, and I'll take one more example, and the motive here is to show you that there could be scenarios where you have a series of numbers and they are not in an arithmetic progression. So let me take this series. This series is something like this. So if you have a series like this, now the question is the same: if this particular series, what you are seeing here, is an arithmetic progression or not. Now what you find here is that the first two terms have a difference of 3, but the next two have a difference of 6. The third and fourth term have a difference of 12, and then the fourth and fifth term have a difference of a5. So can we say that ak plus 1 minus ak is a constant num d? No, we cannot say that. D is not the same. So this kind of a term, this series is not an arithmetic progression or is not a AP. This particular series is not an arithmetic progression. So I think with these two small examples, you have understood that how exactly you can infer whether a given series of numbers is an arithmetic progression or it's not an arithmetic progression. Okay, let's move on to the third concept. So this concept is basically about finding the nth or the general term of an arithmetic progression. So let's say I'm having an arithmetic progression, and I'm going to take the same example 2, 5, 8, 2, 5, 8, 11, then I take 14, followed by 17, and then let's say 20. So let me try to write down these numbers vertically, and then we try to infer them. Let me just keep it to first 6 numbers maybe. So the first number is 2, the second number in the series is 5, then 8, 11, 14, and 17. Now if you see, this is nothing but the first term, which is 2. How did we get the second term? We got the second term by adding 3 ones to this, right? So how did we get the second term? The third term, we got it by adding 3 2 times to 2, and the subsequent term we get by adding 3 times 3, and then we add 3 4 times, and then we are adding 3, 4, and 5. So this is how we are building these numbers, that every time we are getting it, getting the subsequent number, we are adding 3 to the current number. Now can I say the first number was a, and the second was a plus d, the third being a plus 2 times d, the fourth is a plus 3 times d, the fifth is this, and the sixth is this. So let me take a quick look at what we have written here. What we have written here is that to get the second term, we added d once to a. To get the third term, how many d's did we add? 2 d's. For getting the fourth term, we added 3 d's. For the fifth term, 4 d's. And for the sixth term, we added 5 d's. So if we have to build a generalization here, can we not say that if we are supposed to find the an, then that is nothing but a plus n minus 1 times d. So 1 time less than the number of term we are trying to find. So we can say that the formula for the nth term is a1 plus n minus 1 into d. This is the formula. Now let's take a very few quick and we have already understood that a1 is nothing but the first term in this case. That is the first term we are referring to. D is the common difference we are referring to, and n is of course the nth term or the nth number which we are trying to find. Now if I quickly take a few examples, if I tell you that you have to find the 20th term in an arithmetic progression, how you should be remembering this formula is, to get the 20th term, I will need to take the first term a. For this, for sake of simplicity, a lot of times a1 is referred to as a. So we will take the first term a, and then we'll add 19 d's to it. If someone asks me what is the 45th term, I'll say that is nothing but a plus 44 times of d. If someone tells me what is the 200th term, it is nothing but 1 plus 199d. So always remember this formula, that it is a, which is the first term, and you are adding the common difference n minus 1 times. You are adding the common difference n minus 1 times. So this is one formula which you will use time and again, a plus n minus 1 into d. Okay, let's move on to the next concept, which is basically how to find the 11th term. We will do this, basically we are trying to find a particular term from the end of the progression. So what you have here is, the question is find the 11th term from the last term towards the first term of the AP. So you are given an AP which is basically a decreasing AP in this case. You are seeing that the first term is 10, then you subtract 3, you get the second term 7, then you again subtract 3, you get 4, and subsequently you keep going until you get the last term is minus 62. So there are two ways to do this question, and let me start with we'll go through both these ways, and you should kind of understand both the ways, because they are you will have the flexibility to pursue any of these if you see a question in the future. So the first method is that what I am seeing here is a decreasing AP, and I am kind of more comfortable with an increasing AP. So one thing we can basically do is we can flip this AP and we can say that this AP's first term is minus 62. And then when we add 3 to it, that is minus 59, and then minus 56. And then you keep going to find 4, 7, and 10 as the last term. So what we did is we flipped this arithmetic progression. We said what was the last term, minus 62, becomes the first term, which is minus 62 in this case. And now the question is simple. You have to find the 11th term from the starting. And 11th term, now in this case, what you know is that the first term A, happens to be minus 62. D happens to be 3. This is an increasing AP. You are adding a positive term to every term to get the subsequent term. And what we have to find here with these values in mind, we have to find the 11th term, which is nothing but A plus 10 D, which you can write as minus 62 plus 10 times 3. So it becomes to minus 62 plus 30 is equal to minus 32. So what we get here is that A of 11 is equal to minus 32 is the answer which we get from the first method. Now let's go to the other method, which is let me put that as the second method. So the first method was pretty simple. What we have done is we have flipped the series and taken the last term as the first term and found this, rather than considering it as a decreasing arithmetic progression, we have considered this as an increasing arithmetic progression. Now let's go for the second way of doing this, which would be the normal way, which everyone would typically try to do it in. So this is the series what you see here, and what we can infer about this series is that the first term happens to be 10. The common difference in this case happens to be minus 3. Now let me try to find out that how many terms this particular series has, because you want to find the 11th term from the start ending. So you need to find that how many terms actually this particular series has. So let me say that an is equal to A plus n minus 1 into D. And what we will do is we will say we know this last term is minus 62. We know the first term is 10. We don't know how many terms are there. So n remains a constant. And then we know that the common difference in this case is minus 3. So this becomes minus 72 is equal to minus 3 into n minus 1. Minus and minus, we can cancel them out and they become plus, and then this becomes basically n equal to 25. So we are talking about a series which has got 25 terms. So let's try to put it in a small simple form. What we are saying is that this whole series has got 25 terms, and what you are interested in finding is the 11th term from the ending. Now the 11th term from the ending would be what number of term from the starting. So let's take a very small example here. With that example, I will show you very simple example we'll talk about here. So what I will do is I will take 5 stones here. Now there are 5 stones, and someone asked me that the second stone from the end, it, when I count from the starting, what number of stone is that from the starting? So from the starting, this is 1, 2, 3, 4, and 5. So the fourth stone from the starting. So if I count from the starting, what I'm saying is the fourth stone is actually the second stone from the ending. If I start counting from the ending, it is the second stone. So if I would have been told that I have to find the second term from the ending, what I would have done is I would have said take the total number, subtract 2 from it, but add 1 to it, and that gives you basically 4. So apply the exact same concept here also. You have got 25 terms. You are supposed to find the 11th term from the end, and that would basically be 24 minus 11 plus 1, which basically becomes 15th term. So what I'm trying to say is, I'm trying to say that the 11th term from end is nothing but the 15th term from start. Is the 15th term from the start, and this is the key point which you have to do, which you have to apply here. You found that the total number of terms is 25. From the ending, if you have to find the 11th term, it is the 15th term from the starting. So now our job is pretty easy. We have to find the 15th term, which is a plus 14d. A in this case would be 10, and you are talking about 14 into minus 3 is equal to 10 minus 42. So A15 becomes again equal to minus 32. So from both the cases, what we get as the final answer 32, that is the first particular, that is the number which we have the 15th term from the starting or the 11th term from the ending. So you should be able to apply both these concepts for finding the nth term from the starting or finding the nth term from the ending. Okay, I think we have covered 4 concepts till now. We understood what exactly is an arithmetic progression. We understood how exactly to find out whether a given series in an arithmetic progression or not. Then the third concept we found, which we discussed, was basically how to find the nth term or a general term of an arithmetic progression. And then the last or the fourth concept which we learned is how to find the nth or a general nth term from the starting or from the ending. So both the ways we explored in this particular thing. Now let's come to the next thing, which is basically the fifth concept here, how to find the sum of n terms of an arithmetic progression. So I'm going to explain this through a very simple example. I'm going to take a simple arithmetic progression, which is 5, 10, 15, 20, 25, 30, 35, and 40. Now you see here that I am basically keeping this as a short arithmetic progression with 8 terms. Now the task at hand is I have to find out the total of all these terms. So I have to add 5, 10, 15, 20, 25, 30, 35, 40 and find that what is the sum total of all these n numbers. So moving on to the next concept here. So what I have put down here is a series which is basically 5, 10, 15, 20, 25, 30, 35, 40. And by sheer observation, what I'm seeing is that when I add the first term, and the last term, I get the value 45. When I add the second term and the second last term, again the value is 45. The third and the third last is again 45, and the fourth and fourth last is again 45. So what I'm observing here is that A1 plus A8 is 45, A2 plus A7 is again 45, A of 3 plus A of 6 is again 45, and A of 4 plus A of 5 is again 45. Now, if I have to basically add up all these numbers, am I not going to do a 4 multiplied by 45? And 4 is, so 45 is nothing but, let me call this first term as A, and let me for a minute think that the last term I will call it as L. So basically what we are seeing is that A plus L is equal to 45, and we are multiplying it by 4, which is nothing but half the times the numbers which we are having. So can we not say that the sum of n terms is nothing but n by 2 into A plus L? So half times the sum of first and last term. So this is what becomes the formula. Sn is equal to n by 2 into A plus L, where my L is nothing but the last term. So let's try to you will not always have the last term. So, but the last term you can always find by doing a plus n minus 1 into d. And when you will simplify this, you can write this as 2a plus n minus 1 d. So either you can understand and learn it in this way, or the other simplified way is this way. Now, one important thing I want to cover here is that, so this is these are the two formulas which you have: n by 2 into 2a plus n minus 1 into 2, and n by 2 into a plus l. Now, one important thing what I want to do here is I want to take an example which has odd number of terms. So 2, 4, 8, 10 and 12. So I'm going to take a very simple example and with odd number of terms. So when I say odd number of terms, I'm saying that this particular example has 5 terms. The previous example which we saw had 8 terms. Now in this particular example, let's try to do the same thing. The first and the last value are added, so they give the total as 14. The second and the second last values are again 14, and sorry, I took a little bit of an incorrect example here. Let me correct this example quickly. The example I wanted to take was 2, 4, 6, 8 and 10. And I say that the first and last term is 12, the second and second last term is 12, but we have a left out term in the middle. So if we have to find the sum of this particular series, we are talking about a 12 plus 12 plus 6. 12 is very simple. This is a plus l. This 12 is again very simple. This is a plus l. But what exactly is n? This is, what is 6? A plus l by 2. Can I not say that what I'm talking here is 5 by 2 into a plus l? So again, the form n by 2 into a plus l still holds true even if I'm talking about odd number of terms. So that is the important inference here, whether you have an even number of terms or whether you have an odd number of terms. In both the cases, what you can work with is these two formulas for finding the sum of n terms. But always remember the formula as half times n by 2 times the sum of the first and the last term. So that's the way how you remember this formula. Similar to, so basically understand the formula with the concept behind it. That's what I'm trying to call out here. Okay, now let's move to the next example, which is finding n term using the sum of a series. So this is, again, I'm going to do it as a very simple example. I'm going to take a very simple series: 5, 15, 25, 35, 45 and 55. So what I will do is I will try to find, this is, you don't have to learn any particular thing here, but it's a very simple concept here. Let's say you have a series of 6 terms and you would have known what is the value of the sum of the first 6 terms. So that is nothing but n by 2 into a plus l. So I would typically do 6 divided by 2. It is 5 plus 55. It comes to 3 in 3 times 60, which is basically 180. So the sum of first 6 terms of this series is 180. And let's say I have to find the sum of the 5 terms also I know. So that comes to 5 by 2 into the first term now is 5 and the last term becomes 45. So it becomes basically 5 by 2 into 50, and that is basically 125. So what we are trying to conceptualize here is that it is given. So let's say if you are given that the sum of 6 terms is 180 and the sum of 5 terms is 125. What we are trying to say here is that the difference of S6 minus S5 would give you the 6th term in this case. That's all we are trying to say, that sum of n plus 1 terms minus the sum of n terms is nothing but the nth term in this case. So this is what we are trying to give the formula, that an is nothing but the sum of n terms minus the sum of n minus 1 terms. So pretty generalistic thing. If you ever have a scenario where you know the sum of 6 terms, 5 terms or 8 terms and 9 terms, and then you can find the particular term which is there in these particular, by finding the difference of these two. So this is just a concept to remember in this particular case. Let's try to summarize what we have learned in this particular whole concept series session. So we have learned around 5 to 6 concepts. I'm going to put down these concepts just as a summary. So what exactly is an AP? So I'm going to write down the definition. An AP is a list of numbers. So it's a list of numbers in which each term is obtained by adding a fixed number d to the preceding term. So this is a concept which you need to remember, that if first term is a, second term would be a plus d, third term would be a plus 2d, then we go on to find a plus 3d. And what we remember here is d can be positive, d can be negative, both cases are possible. D can be positive or D can be negative. The second concept we learned here is, for an AP, basically, we learnt that A of k plus 1 minus A of k is equal to D. For any value of k, if you find the difference between two consecutive terms, you should get a fixed number, which is nothing but the common difference in this case. Then the third concept we learned is about general term. So we said that an is equal to a plus n minus 1 into d. That is how we found the general term. We also found ways to do nth term from end, and to find the nth term from the end, we kind of covered method 1, and we covered another method 2. Method 1 was nothing but flip the series. Okay, rather than finding the term from the end, you find it from the starting. And method 2 was find, I'm just going to write the example, find 11th term from end is what term from start. In this example, we saw it ended up being the 15th term, which we are talking about. After that, the next formula which we understood was sum of n terms. So sum of n terms, we kind of did two formulas, n by 2 into a plus l, and we denoted it as Sn. We also said this could be n by 2 into 2a plus n minus 1 into d. And the last formula we did is n terms minus n minus 1 terms comes to a of n. N terms minus Sn, sum of n terms minus sum of n minus 1 terms comes to be the general term an. So these are the concepts we have learned. I think from arithmetic progression perspective, what you are going to time and again see is the usage of this formula. One is this formula will get used again and again, and the other formula which will get used is this. This we conclude with these key learnings. We conclude the session on the concepts of arithmetic progression. Thank you everyone for attending this session.